Okay, we are back with Lecture 3, Informal Communication Patterns in Organizations. And this one is kind of interesting because it's something that people don't think a lot about, which is how can you track the way people's communication in an organization when they're interacting with each other is shaping the roles that they might play that you don't normally see because they're not their official roles. So to start with, I want to have you watch a short video about what networks are and how we evolved to a point where we are looking at networks of people rather than things. So we're going to go out and we're going to go to the YouTube for just a second here, and we're going to start.
Network theory is a way of describing the world in terms of a model called a network that allows us to capture the information about the relationships between things. But let's first think about why we might be interested in this at all. We often describe the world in terms of objects or things and their properties. We talk about a country and its GDP, people and their age, or the color of a car. This type of component-based analysis works well when the system we're interested in is relatively isolated. But when we turn up the interactions and connectivity between elements within a system, it is increasingly the connections that come to shape the elements and define the system as a whole. And thus we need a model that captures this information about the relationships and allows us to reason about it. This is where network theory comes in. Network theory starts with a very simple view of the world as made up of nodes, which are things or objects, like people, cities, computers, etc., and the relationship between these things called edges, such as friendships, trading partners, cables, and so on. This abstract representation of the world can be used to model a wide variety of things. Thus we can have social networks, biological networks, or logistics networks composed of interacting suppliers and consumers. Network theory gives us a set of tools for analyzing the individual elements and relations within these networks, the structure of the network, and the properties that these different network structures give rise to. The first set of questions we might like to ask about a particular network relates to its degree of connectivity, that is, how connected an individual element or the whole network is. This will tell us many things about it, such as how quickly a new event could spread or propagate through the system. The average degree of connectivity will give us a quick answer to this. This is calculated by taking the total number of edges and dividing it by the total number of nodes within the network. We also need to take into account how large the network is, that is to say how far it is on average from one point to another. This is called the average path length, and we can calculate it by taking the average of all the path lengths between all the nodes. Because networks are all about connectivity, we often ascribe value to individual nodes based on their degree of connectivity. There are various methods for calculating this, but a popular one, called eigenvector centrality, measures both how many edges a node has and how connected the nodes it connects to are. Popular web search engines use variants of the eigenvector centrality measure to rank web pages by calculating both the number of links into a web page and the total degree of connectivity of the pages that link into them, thus gaining an idea of the relative importance of a website. Next, we're interested in talking about the overall structure of a network. This will be largely determined by how the relations between the nodes was formed. If the relations between the elements was generated randomly, we would expect a relatively even distribution of edges across the network. This type of structure, or topology, is called a distributed network, as the relative importance of any node is distributed across the entire network. A second type of network structure we can get is called decentralized or small world. This is generated by having local clusters of connections, but also having some random distant connections. An example of this might be a group of friends, with some of the friends having distant relatives in other parts of the world. By using these local connections within the group and distant connections, research has shown that it's possible to connect two random people within an average of just 6 steps, and thus it is termed small world. Lastly, we have more centralized networks called scale-free networks. This is where many nodes have chosen to connect to the same node, giving a degree of connectivity that greatly exceeds the average, whilst leaving many with a very low level of connectivity. Many real-world networks are thought to be scale-free, including social, biological, and technological systems such as the World Wide Web, where very few websites like Wikipedia have a very large amount of links into them, whilst the vast majority of websites have very few. These various types of network structures give rise to different properties. A key question we're interested in asking here is how robust or fragile is a particular type of network, as this will not only help us understand networks better, but it will also be of great significance in how we design and manage them. For example, think about a country with many small to medium-sized cities supplying the population with various public services. If we were to remove one of the cities, it would have a limited effect on the overall system because the network has a distributed structure, making it robust to failure of this kind. In contrary, if we take a country with one dominant capital city with the rest of the urban network dependent upon it for core services, this centralized network may be more efficient, but it is also in what is called a more critical state, as affecting this single primary node would have a large systemic effect. As we transit from an industrial to information societies, networks are emerging as a new paradigm in how we structure our systems of organization, both social and technological. Network theory is a young and rapidly growing area that provides us with a set of tools for designing and managing these new types of organization, and more generally understanding the world around us from a different perspective.
Okay, so you can see that this is really a huge area, a very geeky area, if you will, that exist, and I probably more than you even really want to know about networks. But I wanted you to understand that the background of this, the software that exists, and the kind of analyses that can get done on networks, quote unquote, is quite extensive. And really what we're looking at, if we talk about it, is how this network analysis area came to look at people's communication with each other as a network. And it's interesting because electrical systems were used as sort of a model in the earliest 20th century to capture communication. Not surprisingly, because you suddenly have the telephone, the television, and so suddenly people were realizing that communication, right, was using these electrical devices, but also human communication itself, right, was a network. And so you can see how there was this move from sort of electrical systems, even transportation systems, mapped out literally geographic networks to people. Interestingly enough, sociology kind of embraced this network kind of theory in the mid-20th century, and it was scholars like Lewin, one of the fathers of OD, who really had some of the basic applications of network analysis to human communication and human behavior. Now, the difference is, and what we're talking about here, is when we look at communication network analysis, right, and the interconnections between system components, we're really talking about people. So you're going to hear a lot of language early on that sounds very, very electrical or technical, but really we're talking about people. And what we're mapping in this communication network analysis is the relationship between those people, right? Not the actual people, but the relationship, which then goes on to give us, right, that relationship between those people give us certain roles. So it's not the formal job descriptions that someone has, but by the way the communication flows between people, we can identify certain informal roles in organizations. Now, this network analysis is very, very much part of the social media networking. And he mentions in that first video, the algorithms that are used are really the same kind of algorithms and software that are used when you're trying to map communication between people in real life as on the social networks. I have a real quick video. It's only about 3 minutes long, but I wanted you to see this because it is kind of fascinating that they are identifying relationships in social media in much the same way that we're going to talk about it in organizations. So I'm going to escape out again. We're going to go back over to YouTube, and let's play this video real quick.
Before, from the online versions like Facebook and Twitter to the more traditional social networks of people in a fraternity or in a small town. You've probably also heard about some of the interesting things you can learn about these networks when you analyze them. From silly things like hearing how many degrees of Kevin Bacon one actor is from another, or the slightly creepy like how Facebook's algorithms try to predict what products you want to buy or who to add as a friend. When you start to think about the world in terms of different overlaying networks that connect and transfer friendships, information, money, and power, you start to see how analyzing things through the analysis of social networks can lead to new realizations about culture, politics, history, and lots of other interesting topics. We have an intuitive sense that the connections to the people around us are a huge factor in what we know, how we think, and what we do. But researchers using standard statistical methods don't have a really good way to account for the effect of these connections without social network analysis. They can see similarities and differences between isolated data points, but social network analysis gives us tools to quantify those connections between individual points, often in a visual format, so that we can find patterns in the forces that connect us together as a society. We can find out how one person is connected or disconnected from people, groups, or trends in a population. You know those people who seem to be friends with everyone? Well, social network analysis can generate graphical representations that reveal individuals in a population that bridge different social groups. And ever had a friend who stopped hanging out with you once they got a new boyfriend or girlfriend? With social network analysis, you can study how individuals divide their energies between different social groups over time. We can study what makes a group of strangers start to form distinct friendship groups. And once networks are formed, we can see how things like power, beliefs, or even an outbreak of disease flows through the individual connections. As you can tell, there are practical questions that can get quantitative answers and new insights with social network analysis that just weren't possible before. This opens up an exciting range of new options. One example is in colonial American history. What do you think the social network of political leaders in Boston looked like at the time of the Revolutionary War? Duke professor Kieran Healy looked into this and found several distinct social groups, but one name that bridged them together: Paul Revere. Or in the topic of education, how are friendships in a school affected by race and age? In the data shown here, when we see friendships colored through grade level, it looks like there's pretty good diversity between the students of different class years. But when we look through the same friendships colored through race, the friendships start to look much less diverse. If we happen to combine this information with data from other schools, we could see what patterns keep repeating even in different environments, and what makes unique patterns arise. Social network analysis is a very open field, and there are lots of technical options to try out, like adding geographic mapping data to understand how physical environments change network dynamics. And for math geeks, it's still a very new field with lots of room for creating new analytical algorithms that can create new forms of mapping network connections. See the power of social network analysis in your own life right now by looking at the tools linked below to your Facebook, Twitter, and LinkedIn networks. You probably won't expect everything that you see, which is one of the reasons that social network analysis is so exciting. If you're a faculty member, researcher, or graduate student interested in learning more or applying this to your own research, look for listings in the Social Networks workshop.
Okay, so as you can see, there's a huge number of literally softwares that are out there that you input the data into, and they generate this kind of network analysis of the relationships between people. And what we're doing is a very simple version of that today. I wanted to sort of make it simplified, but I wanted you to see just how far and in depth. He mentions Facebook Touch Graph and Twitter's Mind Maps, and you can Google that and you can find out more about that. And literally, you can use that software to see your own social network on Facebook or Twitter. It's really very interesting. Okay, so, oops, sorry guys. This is our same first piece. Here we go. All right, properties of informal networks. So you're going to hear words, links, ties, edges. You heard in those various videos. What we're talking about is the stuff between the components. And oftentimes the components, or the nodes is another word that they use. We're talking about people, right? So we're talking about people and the stuff between them, in this case, the communication between them. And when we look at it in organizations, we can look at individuals as those nodes, right, and their communication. We can also look at departments or work groups, right, and within those departments and work groups, or we can look between departments, right? We can also look at an organization as a whole. So there's a lot of different levels that we can use to look at this with the communication patterns. The network analysis maps the flow of communication from people to people or department to department, right? And the idea, again, is that this is relational, not positional. What we mean is that the flow of communication, right, creates certain relationships that are not necessarily dictated by your formal position in the company. So the fact that you are the manager, right, isn't what gets put into the mapping. The communication that flows from you to your staff may reveal that you are not a bridge or you are not a liaison, but that rather you are just a member of the group. So we take the formal positions out and we look at the relationships between people based on their communication. How do we measure that stuff, those links, that flow of communication? There's a lot of different ways that this complexity of the software can measure these things. We're going to do a very simple one a little later, but I wanted to show you all the different levels of analysis that might be done. So, for example, you can look at types of content. The study that we are going to look at briefly in this lecture looked at the type of content based on work communication, social communication, and innovation communication. Oftentimes, you might look at the type of content in terms of information, education, entertainment, work versus social. So the content itself can give you data. Of course, the channel that you use, again, in the article we're going to look at, they looked at the 3 different channels people used: face-to-face, I think it was email, and texting. I'm not quite sure, but there were 3 different modes that they looked at. Density, in other words, how much back and forth, so how often you talk to somebody, but also maybe how many people you talk to. So there's that density can be both of those. The strength, right? So the strength of the link might be measured in terms of, like I said earlier, the amount that passes between, how much time is spent, or how important you feel that particular relationship is with that other person. The symmetry, right? Here's these words again that we had when we were looking at channels. Same thing, because in effect those links are channels, right? The symmetry being the flow of the direction. Is one person talking and the other person says no, they don't talk to that person? Are the people of the same status? Is there the same strength in terms of, if you go back up, the amount and the time and the importance? And then the multiplexity. And again, I think in the study that we're going to look at in just a minute, they look at the number of different channels and the number of different content that 2 people might exchange as a way to measure, right, the flow and the importance of those links in that particular relationship. All right, so what do? We take all that data and we end up churning out and identifying certain roles, informal roles. Now, these words that I'm going to go through for these roles change depending on what study is being done or how the software uses the labels. But what I want you to understand is that it's really the relationship that you're playing, the role you're playing in the relationship, no matter what you call it. So here's the ones that we sort of take in general. First of all, bridges. Bridges is a member of one group who links to another group. Gatekeepers can be people that withhold information, so they have sort of a central role, or they share information outward. Liaisons can be links between different groups. Oftentimes they'll say liaisons are not members of an individual group, like a manager might not be a member, but they link the 2 together. In most more informal network analysis, a liaison we're looking for is similar to a bridge, but a liaison might play a role in linking several different groups together. Stars, or what we call opinion leaders, are identified not because there's a back and forth in the information, but people come to them, right? Come to them for advice or their opinion. So it's distinct from bridges and liaisons who help the flow of information to go back and forth. Cosmopolites, or we used to call them social butterflies, but that sort of had a negative connotation. Now we talk about them as community builders. But if you think of the visual of a butterfly, right, the people that go out to other people, unlike the opinion leaders that people come to, the social butterfly or the cosmopolite tend to reach out to a lot of people. People might not necessarily come to them, but we consider them community builders because they're the ones that are sharing the information out. Think of people like who are organizers. And then we have the isolates. Again, a very negative word to some extent. We like to talk about them as independents and a little bit more of a positive word. But these are isolates that are isolated because of the amount of communication that they do outward or that comes into them inward, right? And interestingly enough, isolates can be identified as having less job satisfaction in some research, less length of time in a job, and yet you're going to see in the study we're going to look at, the isolates have less stress and less burnout. So the isolate role is one that research kind of finds very confusing findings on. Here's an example of a couple of these roles and these kind of graphs that you get. You can see at the upper top right, the gatekeeper, for example, could be somebody that has one group and then going to another group, but is identified because of the flow of information. So you'd have to measure that by the amount and type of information that's coming through, not just how often and how many people they talk to. In the lower left, I'm sorry, that was the upper left. In the lower left, in the green, the bridge is somebody that connects to two groups. And then you see over on the right, the white dot is a liaison. They're showing that as not belonging to either one of those groups. The star is in the middle of the blue group, obviously connecting with everybody or everybody connecting with them, depending. And then the isolate is in the upper right. Here's another kind of analysis, slightly different, but the same kind of principles. So they've identified three different people, if you want, or three different spots in a network. One is central. You can see the person in the middle connects to a lot of different people. They say they can hold that network together, or that centralized person, that centralized node, if you want to call it that, can also become a bottleneck because that person, everything seems to go towards that person and then out from that person. The dark blue in the upper right, they're identifying as a knowledge broker, right? They have a critical connection, right? Maybe they are bringing in knowledge from the outside and then bringing it into the organization, right? Or between two different groups. And then you see the orangey yellow button in the lower right, they're calling peripheral, right? That's disconnected, is external almost to the whole group. So you notice that their labels, peripheral, knowledge broker, central, are very different than the ones that I just went through. But the actual roles are the same. All right, let's talk about this research study I gave you to read just for a second. I think it gives you kind of an idea of how these network analyses are done when you're looking at communication. So this was a study that looked at the relationship between burnout and stress with support, what they called supportive communication among elementary school teachers. And they did the research with 60 elementary school teachers in 2 schools. They defined the communication that they were looking for, the kind of communication that people had with each other, as supportive communication. In other words, that the amount and the strength of the communication and the ability of the communication to reduce uncertainty. Remember, uncertainty being too much information causing confusion, causing uncertainty. They had 4 roles. Again, as I mentioned earlier, these labels are always going to sound a little different. They looked at people who were what they called linkers, that they had links between more people, that they were more bonded with people, measured by the questions they asked them, and they also exchanged more information. They also looked at what they called group members, right, that linkers would be connected with, and group members were identified because they talked to each other, what we call reciprocal links. They also identified something called a dyad. Interesting, I've never really heard that before in network analysis, but again, I understand the role. The role being someone who has 1 or 2 links, but is not necessarily part of a group, that the links aren't necessarily connected to each other. And then, of course, they had an isolate, which they identified as no reciprocal links. The isolate may link to one person, but there's not a reciprocating link back and forth. So they had all this information, they collected the information and identified these 4 roles, and then they looked at how these people answered their questions, their attitudes about stress and burnout. And what they found was that the linkers had a higher than average stress and burnout, right, on the average scale that they did. That the group members had the highest stress, higher than the linkers, but less burnout than the linkers. So think about that. Those two, the higher than average stress, the higher than average burnout, right, related to maybe the amount of relationship you have, right, and the amount of information you have and what it takes to keep that going, right, might produce stress and burnout, as this piece of research is showing. However, their dyads, those people that had 1 or 2 links but were not part of a group, had lower than average stress, and the isolates had both lower than average stress and lower than average burnout. So this is just one example of how network analysis is used to look at how communication among people can have effects. And it was done in a very simple way, and the way they put it all together. So that's why I wanted you to read it, to give you a flavor. So I'm going to stop here, and we are going to take a break, and I'll come back with part 2 of my lecture, where we're going to look at a very simple example that I asked you all to do, and which I used then to map out the network that you guys have created.